Good morning or good afternoon, ladies and gents. So this is for Mr. Ortiz's Algebra 2 class here at Holmes High School. We're reviewing for our test. We have a test on Friday that's covering solving systems of quadratic equations, solving quadratic inequalities, maximizing area and revenue problems, and vertical motion and decision-making problems. So our focus, we're going to work through this, kind of break it down, show you the steps that you would take on your calculator to graph it or find and interpret your solutions. We're going to first start with solving the system of quadratic equations. Remember, a system is going to be a minimum of two equations, and so we could have a linear graph and a quadratic graph graphed together. Every intersection point represents a solution. So for instance, that point represents one solution, and since it crosses a second time, I have two solutions. So I want to list them. I'm going to start with the squiggly bracket to list my outer pairs. This point is negative 4, 0, comma, and my point up here would be negative 1, 3. And then I can close my squiggly. So we're listing our solutions. Well, don't forget that they could have two solutions, but the line could only touch the parabola in one location, like in the second example. And so this only has one solution, and our solution is 3, 1, our x value, our y value. Okay, as we transition to number 3 and number 4, it's going to require graphing or algebraic methods. We focus primarily on graphing when it came to problems like this nature. So we're going to go and we're going to graph our first one. So x squared minus 4. So we'll make a new document, a graphs page. After I want x squared minus 4. I'm going to hit enter and graph it. To graph my second equation, I want to press tab. Let's see what it equals. So it equals negative 5. So I'm going to type in f2 of x equals negative 5 and hit enter. Remember that a solution is our intersection points. If you notice, our red line will never touch our quadratic graph in blue. Since they never touch, I don't have any solutions. So my number of solutions is 0. And my solution set, well, there's no solutions, so it's no solution. Keep in mind that we also talked about the empty set symbol. And the empty set symbol is like an O with a line cutting through it from the top right corner to the bottom left. Either one of those I'll interpret as it does not have a solution. It does not intersect. As we push on to the next one, we follow the same pattern. So I'm going to graph the first function. Just going to make a new page. So it was x subtract 3 in parentheses squared minus 2. Okay, going to hit enter. Yet again, I have a second equation, so I'm going to push tab. Negative 2x plus 3. So negative 2x plus 3. I can graph them both. What we can see is it looks like it's coming and it's touching it in one location. Sometimes it could be two, but in this case, this is tangent to the graph, which means it touches it in just one location. If I wanted to be sure, I can zoom in. And so we can kind of see that it's crossing through there. I can now find my intersection. Remember, menu, 6. We're going to analyze the graph, and we want to find an intersection point. So 4. Okay. And it's showing me the one intersection point of 2, negative. If I was unsure, I could come back and do this again. So 6, 4. Okay, nothing there. Menu, 6, 4. gave me the same point. Okay, so it looks like we have one intersection point. So we have one solution, and it's the intersection point, 2, negative 1. And we're listing our solution set. Just one point, so I'll put it this way. Okay, so now we start to transition from solving quadratic and linear systems to solving quadratic inequalities. And we're going to focus on an algebraic way of approaching this. And number 7 will start to show you how we can use a calculator as an additional support piece. With these, we started with factoring and finding our roots. So the AC method, we're going to multiply A and C, and we're going to get 12. And I'm going to take B, which is negative 8. So I'm looking for two numbers that multiply to give me 12, and some to give me negative 8. Well, starting with 1 times 12, it multiplies to give me 12, but if I add them up, it gives me a positive 13. But it's positive. The hint would be that I would need two negative numbers to multiply to give me a positive 12. But that's the only way they would sum to give me a negative value. So that gives me negative 13. That's not correct. So I could try another set of numbers. So maybe the next one, I could try 2, negative 2 in this case, times negative 6. So negative 2 plus negative 6, ooh, that gives me negative 8. That's good. From these two values, I can write my factored form. And so my factored form is going to look x subtract 2 in parentheses from here, and x minus 6 in parentheses, and this is greater than or equal to 0. At this point, I can come and I can get my factors. Oh, I'm sorry, we have our factors, so what we can get is our roots. Remember the relationship between our roots and our factors. Ideally, we were setting this equal to 0 and solving it, and what we came to understand is, I'll put it right here, that they underwent a sign change. So x equals 2, and x equals 6 would be my roots. This has a bar, so that means I'm going to have a solid dot at 2, and a solid dot at 6. What we want to do now is test intervals. So we have this left side section, the middle section, and the right side section. And we want to know which piece should be shaded, which piece represents a solution set. Well, what I want to do from here is I want to pick some points. Any number on this side is going to work. You know, I'm going to take this as a test point. So my left side test point is 0. My middle test point doesn't matter, so I'll try 4. And my right side test point, I see 7 there, or 8, 9, 10, or so on. What we're doing is we want to test each one. Is it true? Well, so we actually start. We're going to take 0, and we're going to plug it back in up here where we began. So what's 0 squared? Minus 8 times 0 plus 12. Is that greater than or equal to 0? So I want to test this to see if it's true. 0 squared gives me 0. Minus 8 times 0 gives me 0 plus 12. So 0 minus 0 is 0 plus 12 is 12. Is 12 greater than or equal to 0? So we get, that's a true statement. 12 is definitely greater than 0. So we know the left side piece is true. So we're going to shade that. And in each way, I'm going to test my intervals to see if they work. So I could go to 4. So we have 4 squared minus 8 times 4 plus 12 is greater than or equal to 0. So this is 16, 4 squared minus 32 plus 12. 16 plus 12 is 28. Minus 32 is going to take me to negative 4. Is negative 4 greater than or equal to 0? We should say false at that point. So that means I don't want to shade this middle area. I'm going to leave it alone. Not going to do anything to it. Looks like we're going to need some more space. We need some scratch paper here. So my other one is testing the last one. So 7 squared minus 8 times 7 plus 12. And is this greater than or equal to 0? Well, 7 squared is 49 minus 56 plus 12. Is that greater than or equal to 0? 49 plus 12 is 40, 50, 9 and 2 is 11, so that's 61. Minus 56 should be 5. 5 is greater than or equal to 0. Oh, we got another true statement. So that means up here, I want to shade my right side tail as well. In order to write our solution set, well, I want all the numbers that are less than 2. 1, 0, negative 1, negative 2. All of these are less than my root at positive 2. So x is less than or equal to. Why is it equal to? Because we started our problem with a bar. So my solution set has a bar. Or these numbers, 7, 8, 9, 10, they're all greater than 6, so I get x is greater than or equal to 6. Keep in mind that if I had to write this as an interval, this is going all the way to negative infinity, and it comes all the way to 2, and stops with a solid dot. So I use a bracket to show that. I union the other piece, which goes from 6, solid dot, so I have a bracket, all the way to infinity, forever to the right. Remember, infinities do not have a bracket. It cannot equal infinity. Okay. So we're going to take the same method, the same approach, to number 6. So as we start this one, we started in the same way. So AC is 1 times negative 4. So that's negative 4. And my B is positive 3. So what two numbers multiply to give me a negative 4? Well, a negative number means I need one negative, one positive. So let's try it. Well, I could do 1 times negative 4. But 1 plus negative 4 equals negative 3. I'm so close. It's the same number, but a different sign. So I'm going to change both of these signs. That sign changes. That sign changes. Now let's try it again. Negative 1 plus 4 equals, positive 3. That's what we were looking for. So yet again, these will become my factors from here. So we have, and I have space here. So we have x minus 1 times x plus 4. And this is less than 0. Like we did before, in order to get our roots, like we did over here, on the other side, so x minus 2 times x minus 6, and then we change their signs. So following the same pattern, my root is a positive 1, and another root is at negative 3. What's different this time is we don't have a bar. No bar. So that means that at 1, it's going to be an open dot, and at negative 4, an open dot. Okay, at this point, it's time to take out some test points. So Any number over here on the left side is going to work, so I'll take negative 6. Yeah, you could have used negative 5. I like 0 as a test point. It's an easy one to do by hand. And I'll take 2 as a test point. Keep the number small. Okay. What I'm going to do is change colors really quickly. Alright. So, yet again, we're going to go back to the original equation that we started with, which was x squared plus 3x minus 4 is less than 0. So, negative 6 squared plus 3 times negative 6 minus 4, is this less than 0? So I get 36 minus 18 minus 4 is less than 0. 36 minus 18 is 18, minus 4 is now 14. Is 14 less than 0? And that's not too bad to make our decision. So it's false. So my left side tail, I'm going to leave it alone. Not going to do anything to it. Alright, so on the other side, now I need to test 0. So 0 squared minus 3 times 0 minus 4, is that less than 0? So 0 squared is 0, minus 3 times 0 is 0, minus 4. Oh, well this just becomes negative 4, is that less than 0? Alright, so negative 4 is definitely less than 0. So it's true. Our middle section tested true, so we're going to shade this in. And hopefully some of you at this point are noticing a pattern in our solution sets. We'll still test the last point, and then we'll write our solution set. So the last point would be 2 squared plus 3 times 2 minus 4, and is that less than 0? So I get 4 here, plus 6, minus 4. 6 plus 4 is 10, minus 4 is 6 again. So is 6 less than 0? Definitely not. So I'm not going to shade the right section. So my solutions are stuck in between 2 points, and in class we've been calling that a sandwich. So they're sandwiched between negative 4 and 1. So it's negative 4 less than. We had no bar from before, so we won't put a bar there. X less than my right side point, 1. Keep in mind it's always a less than symbol here because this number is less than, always less than this one. Negative 4 is less than 1. Last part, so it goes parentheses because there's no bar there, negative 4, or it's an open dot, all the way to 1, open dot again, so parentheses. Okay, so at this point, we're going to start to transition to number 7, where this is one method. You can do it algebraically, you can analyze by hand. But, you know, we can also use a calculator. And especially for ugly values, like 1.33. So, we'll go to the next slide, number 6. Sorry, number 7. And we're going to focus doing this one all on the calculator. All on the calculator. Although, I will give us kind of step-by-step what we should do. If I want to do all calculator, 3x squared minus 8, I'm going to start by graphing this. So in my function, I'm going to graph 3x squared minus 8. What I'm going to do afterwards is I'm going to press tab, and delete the equal sign. And then I want to graph y is greater than 2x. So now I'm using the right side of the inequality. So we know how it's set up. Let's go do it. So I'm going to make a new page. We had 3x squared, subtract 8. Okay, set to press tab. Oh, and and delete the equal sign. So I can choose my inequality. I want to make sure I have the right one. So it's a greater than symbol. And it was 2x. I'm going to graph it. Okay, nice. I'm seeing my intersection points. And the shading part is not shading the vertex. It's not shading this piece down here. So since it's not shading the vertex, it's shading these two side pieces. So first, let's find our intersections. Menu 6-4 again. I'll find this one first. And find that one second. Okay. Our inequality has x's in it. So I'm concerned about my x value here, negative 1.33, and my x value here, 2. So to give us a number line representation of the solution, so negative 1.33 and 2. And since it's not shading our vertex down here, it's not covering the middle part of the graph. The vertex is in the middle. So it's covering the outer two pieces, because that doesn't have a bar. These are open dots. And now I can write my solution set. So I could say x is less than 1.33, well, negative 1.33, or x is greater than 2. At this point, I can write my interval notation. This is less than negative 1.33. It's going forever less than, so that's taking me to negative infinity, all the way up to negative 1.33. Union. This one starts at 2 and goes greater than 2 all the way forever. So that's comma infinity. And now we have our solution in both formats. Inequality format came first, and interval notation came second. Okay, at this part, we start to transition into word problems, situational problems. So now we're looking more contextually at situations. With number 8, this is a reminder about vertical motion, and this equation that we use in physics and we use in applied Algebra 2 problems. Well, Algebra 3 and above as well. Pre-calculus, you'll see it again. So, one of the things to focus on is, I need to know my initial height. I need to know my initial velocity. And then I want to write my vertical motion equation. And you have to be careful. A rescue party approaches a mountain climber on a ledge 49 feet above the ground. I have to think, okay, did the rescue party approach the mountain? Okay, so where's the rescue party? Are they 49 feet above the ground? Where are they starting at? Oh, it's not the 49 feet. They're on the ground. They're below this person. So this piece of information doesn't tell me my age now. I have to read on. The rescuers can throw a rope upward at 52 feet per second. Feet per second is velocity, because velocity is the change in distance per change in time. And they say that they're on the ground. So from the ground, we have to assume a 0 initial height. So setting up our equation, negative 16 t squared plus 52t plus 0. All right. And the connection that we made in class here was that this could be y equals negative 16x squared plus 52x plus 0. So when you get your vertex, we have to understand that the x value represents my t. And the y value represents my height. Okay, so let's go find this. We're going to graph it and find it. I'm just going to make it a new graph page. So we have negative 16x squared plus 52x plus 0. And yes, you're right that if I don't want to put the plus 0, I don't have to. Adding 0 to something doesn't change it. I will just for the sake of the substitution aspect. So I graph it. One thing to keep in mind, and some of you are forgetting this, the negative 16 there, it needs to be a negative 16 because gravity's pulling us down, not sending us up in orbit. Okay, so I want to find this max. Menu, zoom, and I recommend zoom fit. It's going to try to fit the graph to a nice window. And then from there I can zoom in or zoom out so I can better see it. So I can see my vertex up there. Hey, I can go find it. Menu. Analyze that graph, and we call that high point a maximum. Okay, so I have 1.63, comma 42.3. Let's go record that point. So 1.63. 42.3. Okay, so keep in mind that our focus was, now we go back to that 49 feet. Well, okay, let's compare this height, where that mountain climber's at, and let's compare this height. If this is the maximum height that they can reach, would they ever be able to get it to the mountain climber that's stuck? Well, 42 is less than that 49, so we could say no, because so our climber is 49 feet above them. So keep in mind that graphing this, plugging in your values, and finding the vertex are things that we've done and we're solid at. So it's really good to focus on the interpretation. Don't just say no, don't just say yes. Say no and back it up why using the information from the problem and that you gathered from your technology component, the calculator. Okay, so we're going to move on to a second one. Now this one starts to follow the same pattern. They give me an initial velocity upward. They give me an initial height that the baton is released from. So I know my h naught is the initial height. I know my velocity is a feet per second. They even say velocity here. And so we can write our equation. So negative 16t squared, the effect of gravity pulling down in feet per second squared, plus our velocity times the time, plus 6. The other part that's going to be special here is I'm going to graph this equation, but they start to talk about a bird's flight downward can be modeled by this equation. So this bird swooping down could get hit by this baton, and so we're going to graph this equation and find out, do they really intersect? So could it possibly hit? And if it does hit, when? And how high off the ground? Okay, so we're going to graph our first equation. Remember, it's going to be like y equals negative 16x squared plus 65x plus 6. If you notice, I made a mistake there. It should be plus. So checking your work and making sure that you're typing in the correct equation is big. You definitely want to do that. Okay, we got it graphed. Now I want to graph the other one. So I'm going to press tab, and it was negative 4x plus 75. So menu, we're going to zoom, and we're going to fit it. Okay, so I can see what looks like maybe an intersection there. So I'm going to zoom in a little bit. And actually, better yet, maybe I don't have to. Let's try menu, 6, 4. Okay, so what we're seeing right now is that it looks like it did happen. At 2.74 seconds, the bird at the baton would be at a height of 64. We can't say 100% this is going to happen, but we can definitely say it's possible that this bird could hit it at that time and both be at the same height. So 2.74, comma, 64.1. So we can say yes after 2.74 seconds. That's just terrible. Let's try it again. And at a height of 64.1 feet. Keep in mind, on a free response like this, you want to use your units. 2.74 what? Hours, minutes, years? 64.1 miles, meters, yards. Use your units. Okay. As we push on to the last two problems, these require formulation. So when you talk about perimeter and area, maybe drawing a picture is the best way to go. When we did our revenue, talking about money, selling something, and changing that price, maybe making a table would help us better see that. So we may need some scratch paper here. My first thing here, they tell me Johnny wants to build a fence using 400 feet of fencing materials. That's important. That's like my perimeter. The fence will be for a rectangular garden. Write an equation that can be used to find the length and width that will give the largest possible area. Then we want to try to find those. So I'm going to draw my garden. I'm going to label my lengths. And I want to double check in the problem to see if we're removing a side or not using all of a side. It doesn't give us any restrictions, so we assume that we have 2 lengths plus 2 widths, and that equals our perimeter of 400 feet of fencing material. Well, we also have the equation. Area equals the length times the width. Okay, so our first step is to isolate either L or W. Keep in mind this doesn't matter, but since we didn't do it in class like this, I'm going to do it this way just so you can see it once like this. I can choose which way I want to go. So instead, maybe I can subtract the 2L from both sides. So I get 2W equals 400 minus 2L. In order to isolate W, I divide by 2. Keep in mind, I'm dividing everything on the right side by 2. So I get W equals 200 minus 1L, or just L. Okay, so taking this area equation, area equals the length times the width. So I'm going to perform a substitution for my width. So I get area equals the length times 200 minus the length. Last step, so in order to put this in my calculator, I have to understand that it's going to be x times 200 minus x. So I want to graph this, and I want to find my vertex, which should be a maximum, because our goal is we're maximizing this problem. And yes, there's other situations where we minimize. We focus on maximizing that right now. So let's go graph it. So x times parentheses 200 minus x. Close it and graph it. Remember, menu for zoom and A for fit. And at this point, you may start to say, oh, I got a line. I did something wrong. Well, let's zoom out. Oh, I'm starting to see that curviness. There we go. So now I can see my math. So menu, we're going to analyze the graph again, and we want the maximum. So menu 6.3 here. Now remember what we can do. We can click on this coordinate. So here, I'm going to move this coordinate out. You can click on it, and then hit plus. Uh-oh. Okay, for whatever reason, it doesn't want to show it. It doesn't want to do it for me here. So I'm going to click. We'll try one more time. Okay, so it looks like I'm not able to show us that. Maybe I can come back and try it in just a bit. So what we have is we have our coordinate 100, 1, e plus 4. So let's take a look at it. So our vertex was 100, 1, e plus 4. Even without knowing what that is or even the calculator simplify, I can start to figure everything out. Well, connecting back here, x was my length, so there's my length. Y was my area, so that's going to represent the area. We'll talk about that in just a bit. So we know that the length equals 100. So to find the width, I'm going to go back here. What's 200 minus 100? So my width is 100. And so if I do the area equals my length times the width, I'm going to multiply 100 times 100. And so the area equals 10,000. We want to use units, feet squared. So kind of going back to this guy right here, what is 1 e plus 4? This is the same thing as scientific notation, so it's 1 times 10 to the 4th power. And so this times 10 to the 4th power, it's like I have a decimal point right here, and I'm going to move the decimal point 1, 2, 3, 4 times. Each time I move it, I'm adding a 0. So you can see how it got the 10,000 squared. Keep in mind, your calculator rounds, so sometimes you want to double check by multiplying at the end to make sure it's exact, it's accurate. Our last problem takes us to a revenue type problem. And, oh, hold on. Units, remember? Okay, so in this problem, it may help out to kind of think about it like this. Carrie's a street vendor, sells hot dogs for $4.25 each in Chicago. She sells to an average of 555 customers who purchase one hot dog each. She estimates that for each increase of 25 cents, she will lose 15 customers. And we want to know what price should she sell the hot dogs to maximize that revenue. So in this case, X is going to be my number of 25-cent increases. And my Y is going to be the revenue. So this is our focus. We want to maximize the Y. I can start with the table. And we can talk about the customers. And we can talk about the price that she wants to sell them at. Well, if she doesn't increase the price by 25 cents, then she still has her 555 customers. And the price is still $4.25. But if she increases it once, well, she's going to lose 15 customers. So now we have 540 customers, but the price does go up by 25 cents. We can do it one more time. So I lose 15 more customers, so it would be 525 customers, and now I make $4.75 per hot dog. So I can write an equation. If I talk about x increases, then this is 555 minus 15x. So what I started with, and that I'm decreasing by 15 customers every time we increase the price by 25 cents. Over here, we started at $4.25, and we add 25 cents every increase, so times x. From these two equations, now I can start to set it up. So my revenue, in this case, since customers purchase one hot dog each, it's going to be my number of customers multiplied with the price. Then we would know how much money that Carrie made on this day, or on any particular day. So we're going to get y equals 555 minus 15x times 425 plus 0.25x. So let me clean this up a little bit. So at this point, now I'm ready to set up my equations and to grab them and find that vertex. So we're going to do that, and we're going to set it up just the way we see it. So it's parentheses, 555 minus 15 customers every increase, close the parentheses, open parentheses. We start at $4.25, and we add 25 cents every time we increase. Remember, we don't see it, and that happens. So let's go menu, zoom fit. All right, I can see my curviness. So now we just want to zoom out a little bit. And I can see that max. Let's find it. So menu, 6, 3. All right, let's try it again. Let's see if it works. So I'm going to click on this. There we go. So if it doesn't work, remember we can multiply those values out. So we can double check how they got that amount. So we're saying that this is my number of increases, 10, and there's my maximum revenue. Let's go write that down. 10, 2733. So 10, and I believe it was 0.25. I'll double check. Oh, it was 7.5. Okay. So the last things that we have to do is, the question was, what price should she sell the hot dogs to maximize her revenue? Well, the price equation's here. So price is $4.25 plus 25 cents for every increase of x. Well, there's our x. So what's 4.25 plus 0.25 times 10? So I want to know what's 4.25 plus 25 cents times 10. All right. So now we know that they're going to sell each one for $6.75. I hope you would not buy a hot dog that was $675. Just to finish off the problem, so if you're not understanding why is that the revenue, where did that come from? So let's talk about customers. So that's 555 minus 15x. So what's 555 minus 15 times 10? Okay, so 405 customers. Well, and our revenue over here was multiplying customers and price. So my revenue equals $6.75. Or I guess if we go in the order that we had, 405 customers times $6.75. What does that equal? And now we can see where that Y value makes sense. $2,733.75 represents my maximum revenue, or in this case, carry. But keep in mind, we didn't have to go this far. We were answering the question, which our price is $6.75. However, so you could understand and see all the components, because we could ask you for the max revenue, we could ask you for the customers. This concludes your review. We'll be testing on Friday, just another reminder. Good luck, ladies and gents, and we'll see you then.